Today we'll be making this squishy marble satisfying animation. There are two major parts of this animation, the marbles and the surface. Since the animation for the surface depends on the animation of the marbles, we'll start there. The blend file is available through a link in the description, so check that out if you'd like, and let's get into it. So let's start with our initial points. If we look at this viewer node and we turn on the viewport overlays, we can see that our initial points consist of this line. I'm going to press / to isolate just that object. And so the points are just the vertices of this. We convert to points if we'd like, but it's okay just to keep it as a mesh line. So all we're going to do here is we're going to start with a basic mesh line going from 0 to 1. The z can be a 0. We don't really care about the other thing. And yep, that's going to be just fine. And we're going to change the x and z values of the positions of each mesh line point. So what we're going to do is we're going to take the x position, which is -1 to 1, so -1 to 1 here, and this one is 0. And then we're going to multiply that by some floating point value, in this case 2.5, and that's just going to determine how wide everything is. So 2.5 is the value that we've chosen. And then for the z animation, so if we don't have that, it's just a line. That's just a certain length depending on what you have there. But the animation is all in this animate z coordinate little group. So what we're going to do is we're going to take the scene time. We're going to divide by 20 because our looping time is going to be 40 frames. So 20 works, especially since we're ping-ponging. And then we're going to multiply the index. So the 0, 1, 2 attributes of the points in the line by some value, and this is just going to change the rate at which the lines are offset from each other in the animation, or the points are offset from each other in the animation. So 0.7, this is just something that looks good. I'll show you later how we can play with that. And then we're going to add those together. So just take the time, add the index multiplied by some value, and so that will offset the change by time. We're going to ping pong, so let's actually remove these last two nodes. You'll see what ping pong just goes up and down between 0 and 1 if we set the scale to 1. And then we're going to use a float curve to make that a little bit smoother. And so at the bottom of that 0 to 1 is going to be this, so we're going to smooth that out. And at the top we want it to hang a little bit like this ball is bouncing, so we're going to make that a longer, more gradual curve. And so then you have this here, but it's not going as high as we want, and so what we're going to do is use this multiply add node. We're going to multiply by 8 to make it go 8 times as high or low, and we're going to add, or add -4, which is subtracting 4, so that it goes negative. If I just multiplied by 8, it would go up to 8 and then stop at 0, but we want it to go below the surface, and so we're going to add -4. So just take the output of that and plug it into the z component of the combine xyz node, and then put that into the offset here. And we have our finished point animation. So now what we want to do is we want to instance marbles on that point. Our marble instance is just an icosphere set to 4 subdivisions and a radius of 1, set to shade smooth, and then we're adding this original position attribute, which we'll use in the material for the marbles later on. And then we pipe the points that we just made into the instance on points node as the points input, and then the marble instance is the instance, and then we get this. The only other input we're using here is a rotation input, and that's just so, here, let's look at it in the context of the render, so that when it's playing you see this little rotation on the marble. It just makes it look a little nicer. If I took that off, it's just slightly more boring, and we don't want super boring animations. So the way that this marble rotation works is you're just taking the scene time, the frame output, so just like the frame down here, dividing by 40 because our perfect loop is going to be 40 frames, multiply by 2 times pi, so that it goes through a full circular revolution, or it just does one cycle through the 0 to 1 range in 40 frames, and then pipe that into our combine xyz node, and that so that it rotates around the y-axis, this axis going like that, and then it rotates like that. We could do the z-axis and it would rotate like that. That looks pretty cool too. Or the x-axis. I mean, think I like the y-axis, so I'm going to stick with that. Then we're going to set the instance index, just using the index attribute node on our instances, and we're going to use that in our material later on to change the pattern on all of these. So if this was all the same, then all of these marbles would look exactly the same, but if we set the index, then in our shader nodes we can change the pattern on the marbles to make them unique. We're going to realize instances, and we do that because in the surface object geometry nodes, it uses the actual geometry of the marbles to create the squishy effect, and so we have to realize the instances, and if we don't, then just nothing would happen to the surface. So M to unmask that node, and then we're going to set the material to marble material, and that's all of the nodes for the marbles. So moving on to the surface, we'll start over here just with a simple grid. So this is just a grid set to size 16 by 16 with 128 by 128 vertices. And then the first thing we're going to do is we're going to conform this grid to the marble geometry. So if I pop that viewer node on, all this is doing is conforming the when the marbles go below the surface at z equals 0, it conforms the surface geometry to the marbles, and this could be any geometry. It doesn't have to be spherical. So the way that this works is you take in an object info node with the marbles object as an input, and so we get that geometry, and then what we're doing is we're ray casting from below the surface, somewhere really low like down here, up, and then if it hits the marbles, the ray cast, so we take we're going from 100 below the surface, below 0, so the position of each point minus 100 in the z direction, and that's our source position. So we're starting down here, and then we're shooting rays in the ray direction 0, 0, 1, so just up, and the ray length is capped at 100 so that we don't end up hitting marbles up here. If I take that out, then 100, let's do like 1,000, then it'll conform even when they're above the surface. So we want to set that to 100, so we just limit it to the ground plane. And then if there's a hit, we're going to set this squished Boolean attribute that we'll use later on, which just says like, oh, this part of the plane has been squished by the marbles. And then also, if it has been squished, we're going to set the position to be the hit position, which is just setting the position to be whatever the output of the ray cast is. Without that, nothing happens. But the only issue with this, I mean, clearly this is not like super satisfying or anything like that, and it needs to be smoothed out. And so we're going to do that with this smooth if lower node group. And what this does is it takes the output of the conforming operation, and then it smooths the grid surface if the output of the smoothing operation is not higher in the z position than the output of the conforming operation. And let me explain why we do it this way. So if I just open this and hit this sticky right here, then I can keep this viewer node and dive in here so we can just see this without losing our viewer node. And what we're doing in this smooth if lower is that we've got a repeat zone, and so we're bringing in our geometry, and then for the number of iterations that we set in this outer node group, so 8 in this case, we're going to set the position based off of the blurred position of the point, and we're going to just set, and we have this switch node, so we're going to set it to be the blurred position if the z position is less than, so then if this is greater than, so if the z position, the original z position, is less than the blurred z position, then we're just gonna set it to be position. So we're just not gonna do anything, not gonna change the position of the points on the grid. But if it's not, then we're going to set the position to be the blurred position. And if we don't do that, if we just did the blurred position, like let's hop out of here and just do, like we wouldn't need nearly that complicated of a node group. So let's do blur attribute and then set that to vector, bring in a position, and just blur that position. And go into a viewer node. And this, and set the iterations up. You'll see that, well, not only are we going to have the edges come in, and we could solve that by only blurring the Z position, but also you can just see that, like, the more I blur, these values go up, and then it's kind of like, you know, you're not really conforming to the marbles anymore. So that node group solves this by only blurring them if the blurred position is lower than the conformed position. And we do that twice. We do that again because you can kind of see here that because it's only blurring if it's higher, you get these sort of like jagged edges, and we just do that again with just 4 repeat iterations and 1 blur iteration to smooth that out. So now we've got this animation, which is fine, but it's a little boring. So we're going to do one last twist, which is basically the rest of the entire setup, which is going to end up making everything, here, let's just look at the end, like echoey, smoother, because there's a little bit of feedback, and what I'm calling this is just like a lazy interpolation. And so the way this works is that we're just taking the original grid as an input to a simulation zone, and then we're getting the interpolated position of the output of our smooth if lower node groups, so our conformed and smooth deformed position, and we're setting this interpolation attribute, and then based off of this, every frame we're setting the position of the original grid based off of an interpolated position between the position of the original grid and the position of the deformed grid, the squished grid, by a factor of that interpolation attribute. And the interpolation attribute, each frame, is changed by this little node group, where basically you're interpolating between the last value of the interpolation attribute and the squished value. So if I just show you what that looks like here, I want to look. So the white values are squished. So if I just do / let me look at this. These are the squished values, and so we want, we definitely want this grid to kind of, the closer it is to being super squished, to interpolate towards the deformed grid value, because that's what's being affected most by the marbles. So we take that squished value, and then we're multiplying by 3 and adding this 0.025, and we're just sampling it at the point index of our current point. And then we're mixing that with the previous interpolation value, and then we're blurring it as well just to smooth it out a bit. And so what that ends up looking like is this, and that's what gives us our nice, smooth, sort of echoey interpolated animation. So these values I've just played with, like the 16 iterations, the factor here, the multiplier, and the addendum. This basically is just an artistic operation. You can do whatever you like with it to figure out what you like. So I'm going to press / again so I can see everything, and 0 on the numpad to go into the camera view. And that's really everything. After that, all we're doing is set everything to shade smooth. I'm going to remove this top. Oh, I messed up splitting areas. Here we go. We're just setting everything to shade smooth, and then we're adding in the surrounding grid. So if I just show you what I have here, there's no surrounding grid. It's just the squished grid that we started before, but we want to have something in the background, or else when we render, oh well, it's going to render the rendered view. So here, basically you wouldn't have anything in the background. So you need to add that in. And the way that we're going to do that is we're going to take a grid that is 3 times the size of our original grid, which is 16 by 16. So 16 times 3 is 48. And then we'll take, and then we want to delete the center square. So basically you have this grid that's 3 times the size of this grid. And then you want to remove that center square, or else that face will hide the deformed grid. So you can see that here. And the way that you do that is if the distance of a face is less than some small number, like 0.1 in this case, then we're going to use the delete geometry node, and we're going to delete it. And then you join those 2 grids together. So now you have a background grid or a surrounding grid, and you have the original squished grid. We're going to add a 2D vector point attribute named textCoord that is just derived from the position, which is going to act as our texture coordinate for the surface material, which we're setting here. And then we have this bake node that's going to help us get our looping animation. And the way that this is going to work is, so let's say, our animation perfectly loops at 40 frames. And so that's great, right? We should just set it 0 to 40 and then bake. But if we do that, so let's bake that really quick, then you can see when it starts again, because there's this feedback effect from that lazy interpolation. And so what we need to do is like warm start the simulation and then play it from somewhere later on. So the way we can do that is let's warm start from 0 to 40 and set the end to 80. And so let's bake from 0 to 80. And then once we've done that, we can just set our start frame to 41. And then we have this perfect looping animation that looks pretty nice, if I may say so myself. And with that, the only thing that we need to cover are the materials. So let's cover the marble material first. Go up into the shader editor. So pretty simple. We're just using the principled BSDF shader, and we are piping something into the base color and into the roughness, and then we also have this subsurface value set to these settings that you see here. So we're using both the original position of the instance, so that's just sort of the coordinates within the object space of the marble, and then we're also using the instance index attribute we talked about before. So we're just adding the instance index attribute as a coordinate offset to the original position, just so that these coordinates output here are different for each one of the marbles. So we're using this Voronoi texture, and then we're just changing the colors a bit. So if I just pop in that Voronoi texture, you'll see you have this like more rainbow colored thing. So I'm using a separate color node, and then I am squishing the hue by multiplying it by 0.2, and the saturation stays the same, and then I'm just setting the value to 1 because I like the way it looks better than having the value come from the texture node. And then I'm also setting the color to this blue color, which is just an artistic consideration, artistic decision. You can choose other ones to offset the color like that, and then that's our base color. And then we're doing a similar thing for the roughness. We don't really need that. I mean, it looks pretty good without it. Honestly, it might even look better. Yeah, but it just adds like these little rough dots to the surface. I don't know. Have fun, do what you want. This is what I did. So just another Voronoi texture using the same vector space input as the coordinates, scaled by a certain amount, roughness, etc., and then we're just multiplying by 0.4. So it's then you end up having a roughness between 0 and 0.44. And that is it for the marble shader. And then the surface shader, it's actually super similar. It's almost exactly the same, but you'll see these are checkers, or like a checker texture rather than the Voronoi. And that's this random attribute here. So if I set this to random, then you get the Voronoi texture again. But if I go all the way to not random, I guess the most non-random version of that is checkers. And then we're doing the same exact process of, it's a little different, of separating out the color to hue, saturation, and value, HSV, in this dropdown. And then we're combining that back in for our color, and we're squishing the hue, this time by multiplying it by 0.3, Our color here is a little bit different. Again, I can move this around and get different color schemes, like an autumn color scheme there. Control Z. This is what I came up with. And I am using the value in this case. I could set it to 1, but that's too bright. So I'm using the value here because I like the way it looks. Saturation is the same. See it how, ooh, yeah, not, that's okay. But I'm gonna keep that the way it was. And then a similar thing with the roughness. So, you know, another Voronoi texture node using the text chord as an input. This attribute we set in the geometry nodes. Scaled high, something to like 32. You can see the roughness here. If I zoom in, this is like the roughness. So you just get this sort of like surface detail roughness that I think adds a little bit of subtle detail and makes the whole animation look nice. And then we've got our camera set up just from this direction. The way that I usually set these up is I'll create a camera and then I'll go into view and lock camera to view, and then I can just move everything around and find a view that I like and press play, and that's how that works. But I'm going to keep it with what I set before. And I've got 2 suns, so if I turn both off, everything is pretty dark, but a little bit blue because the background color is set to this. And again, an artistic decision. If I turn one sun back on, then I have got a sun that is, let's see, it's just kind of looking down on the marbles, and you want to go into the light settings here and change the angle. Is going to change how big the sun is really, and how soft the shadows are. So the bigger the angle, the softer the shadows, and then a strength of, in this case, 16. And then the second sun I added in because I wanted this highlight here, so that kind of points at the camera at a rather, I guess, shallow angle. I mean, it's like negative. How does that even work? I don't know, but it does, because you can just move it and see how the highlights end up coming out. So I like seeing them here. Without that, you would lose like this right there. And I like the detail about the surface that light reveals. So again, the angle is, I think it's the same as this one, yeah, 32, but it's not nearly as bright. It's got a strength of only 2. And that just about covers it. I hope you enjoyed this. I would call it a tutorial, but I think this is really just a breakdown or what have you. I hope you learned something, and above all, I hope you had fun. Until next time.